All right, let's get back to work. This is the third video for Lesson 2. This is Unit 5, Lesson 2, and in the Google Classroom, it's called Student Facing Tasks 8.5.2. And on your paper, this is the third activity. So it says 2.3, that means Lesson 2, Activity 3, using function language. And you have it on your computer too, where you will enter in your answers. Here are the questions from the previous activity. And you remember those questions. We did those together. We drew the input-output rules if it only had one output. For the ones you said yes to, write a statement like, the height a rubber ball bounces depends on the height it was dropped from. Or bounce height is a function of drop height. So we're going to learn to use the vocabulary function or function of. And when you say it is a function of something, it means it depends on that. It's determined by that. It doesn't have two different answers. It only has one answer. You're going to see examples now from our previous examples. For all the ones you said no to, write a statement like, the day of the week does not determine the temperature that day. So we're going to say does not determine. That's what we're going to say. Does not determine. Or the temperature that day is not a function of the day of the week. Please remember that we are learning what a function is. And for a function, each allowable input has exactly one output. In the previous activity, we answered if it has only one output or not. If it has only one possible output, then it is a function of that. It depends on that. Let's learn. Okay, a person is 5.5 feet tall. Do you know their height in inches? Yes, I know their height in inches because the height in inches depends on the person's height in feet. Another way to say this, the height in inches is a function of the height in feet. And don't worry if that's confusing, just for now, get used to hearing it. I'll type it in. The height in inches depends on the height in feet. Or I can say the height, I can say it, but I have difficult time spelling it. The height in inches is a function of the height in feet. So what that means, if you know the height in feet, you definitely know the height in inches. It depends on how many feet that is. We can say it is a function of the height in feet. It depends on that. And submit your answer. Next one. A number is 5. Do you know its square? Yes, because the square of the number depends on the number. Yes, let me type it in. Yes, I know the number because the square of the number depends on the number. And another way to say it, the square of the number is a function of that number. So whenever you hear someone say it is a function of something, it means it directly depends on that thing. If that thing is something, it has to be this. It's a function of that. It depends on it. Submit your answer. Next one. The square of a number is 16. Do you know the number? No. Remember why? Because the number, hold on, the square of a number is 16. There are two different numbers you can square to get 16. Let's write that down. I spelled that wrong. I want to fix it. No. Because there are two different numbers. You can square to get 16. Those numbers are -4 and 4. Both of those squared gives you 16. Let me type it in. I'm going to change my answer when I type it in, but you can use either one. The square root of 16 does not depend on the input because there are two different numbers that square to get 16. It kind of depends on the input, but not exactly. Okay? You know, I'm going to write this one more time. I think I can do a better job. The input of 16 does not determine the square root of 16. That's another way to say it. The input of 16 does not determine the square root of 16. That's because there's two different answers. Okay, do your best to say it in your words or copy one of my answers so I know you followed along. Next one, number 4. A square has a perimeter of 12 centimeters. Do you know its area? Okay, if the perimeter is known for a square, if the perimeter is known, then you can find the side length because all sides have the same length. We'll call that x in my picture. Then if you can find the side length, you can definitely find the area because that's x times x, or x squared. The perimeter of a square determines the area, or the area is a function of the perimeter. The area of a square, only for squares, not rectangles. The area of a square is a function of perimeter, or you can say function of side length. Okay, submit your answer. A rectangle has an area of 16 centimeters. Do you know its length? No, not for this one. The length of a rectangle. Wait, I'm typing it in backwards. The area of a rectangle. I need typing class, don't I? The area of a rectangle does not determine the side length. We saw that before. The area of a rectangle does not determine the side length. Next problem. This is number 6 on your paper. You are given a number. Do you know the number that is 1/5 as big? 1/5 of the number depends on the number. 1/5 of any number depends on that number. It's not going to be 1/5 of a different number. I'm going to write this another way. 1/5 of any number is a function of that number. So I hope now you're getting used to hearing function of something. It means it's determined by that. 1/5 of any number is determined by that number. 1/5 of any number is a function of that number. One more to go. You are given a number. Do you know its reciprocal? Well, if the number is 0, you cannot take the reciprocal because you can't divide by 0, but any other number you do. The reciprocal of any number except 0 depends on that number. You can also say the reciprocal of any number except 0 is a function of that number. You can choose whichever statement you're comfortable with, depends on or is a function of. They both mean the same thing in math. Phew! Okay, we finished that page. You can follow along on your worksheets, but remember, I'm just checking answers in the computer. This is the 4th activity. 2.4 means 4th activity. Which input-output rules could describe the same function, if any? Be prepared to explain your answer or your reasoning. Okay, they give us these 3 diagrams, and you see it on your screen too. We have the inputs, the rules, and the outputs. Which of these 3, if any, could be the same function? Okay, let's take a look. 7 is the input. Square it, and you get 49. Okay. 10 is the input. Find the area given the side length. Find the area given the side length. Does that mean the side length would be 10? That means side length equals 10, and then this would be the area. Okay, I got it. So 10, I'll draw a picture. Imagine it's a square, and the side length is 10. Then the other side length is 10, so the area equals 10 times 10, which equals 100. Okay, I see, I got it. And then the last one, 10 is the input. Add 90 and you get 100. 10 plus 90 equals 100. Okay, are any of these the same? These two look the same to me. Because in the top function, or the top input-output diagram, 7, and then square it, that's 7 squared. Or 7 times 7 equals 49. Well, that's similar to this one. They took the input 10 and squared it. 10 squared equals 100. So this input-output rule is the same as this input-output rule if you're talking about squares and positive numbers. So if the input for this is positive and you square it, you would get the area of a square. And for the second rule, if they're only talking about squares, you could get the side length and square it and get the area of a square. So the ones that are the same are the first rule and the second rule. Both of those will square the input and get the output. Explain your reasoning. Okay. If the input in the first rule is positive, if it's for positive numbers, then you can square a positive number and get the area of a square. Let me type that in. If the input in the first rule is positive, then you can square it to get the area of a square. And if the side length in the second input-output diagram, if the side length in the second diagram is for a square, then you can square the side length to get the area of a square. So if so, then they are the same function. Both of them do the same thing. These two are the same functions if it's a square, if the input is a positive number. Finally, finish that assignment. In the pages that I gave you, you can read more about this lesson. Let me read it to you. The phrase is a function of gets used in non-mathematical speech as well as mathematical speech in sentences like the range of foods you like is a function of your upbringing. They mean it depends on. What is that sentence trying to convey? Is it the same use of the word function as the mathematical one? Let me read it again. The range of foods you like is a function of your upbringing. So when it's not used in a mathematical way, they mean depends on. The kinds of foods you like depends on your upbringing, like what your mother cooked or what was popular in your community. It depends on that. But when we use function of in math, we mean there's only one possible answer. There's exactly one possible answer. So the kinds of foods you like not only is determined by your upbringing, but it might also be determined by, I don't know. Gosh, now that I think about it, everything is your upbringing. Maybe it's determined by your taste buds. Maybe your taste buds are predisposed to like only spicy food or something. Let me read the summary. Let's say we have an input-output rule for each allowable, let me start over. I forgot the word that. Let's say we have an input-output rule that for each allowable input gives exactly one output. Then we say the output depends on the input, or the output is a function of the input. For example, the area of a square is a function of the side length because you can find the area from the side length by squaring it. So when the input is 10 centimeters, the output is 100 centimeters. If the input is 10 centimeters, the output is 100 centimeters. Sometimes we might have two different rules that describe the same function. As long as we always get the same single input from the same single output from the same input, the rule describes the same function. So we could have two different rules. And remember, the rule is the stuff in the box. I like to call it instructions. Anyway, here's the input, here's the output, and here's the rule. What if the first rule says that the side of a square, the length is x, and the rule says multiply by x. Multiply x by x, and the output is the area. And the other rule says just take the input and square it. Then you get the input squared. So actually, these are the same rules because they're both doing the same thing. So those are the same function. If it's still a little confusing, don't worry, because this was just a warm-up and we're going to talk about this more and more. You're going to get more and more comfortable with functions and what it means to be a function. Okay, I'll stop this long video and you can turn in your assignment.